Hello everyone and welcome to our engineer interview with Amanda. My name is Scott and I'm your host for today. Just before we start, I'd just like to say thank you very much for signing up to this year's competition. For those of you who don't know, this is the Leaders Award competition, where we ask the question, if you were an engineer, what would you do? Pupils in the ages of 3 to 19 anywhere in the UK can take part, and every single pupil receives a graded certificate from a real-life engineer, just like the ones we interview. Now, the deadlines for submission is March 22nd, so make sure that once you've finished the competition in class, you send them to us so we can get our certificates sent out. We're delighted to announce that there are some free posts still available for schools who are looking to submit entries. This has been provided by our national partner, Talis. So if you would like to see if your school is eligible, simply get in touch with your contact at Primary Engineer and they'll let you know how to take advantage of the service. Now, during these interviews, we're going to be speaking with engineers who work on loads of different projects, all of them showing the wonderful, interesting and exciting things that happen when you work in engineering. Our special guest today is going to start with a presentation all about National Grid and the role of electricity, and then we're going to follow that up with some questions. If you would like to ask a question, simply type it in the chat and we will ask them out to Amanda at the end. But for now, I'm going to hand over to Amanda, who's going to start her presentation.
Thank you very much, Scott. Hi, everybody. So my name is Amanda May, and I'm a chartered electrical engineer, and I work at National Grid. So I live in Leamington. I have 3 children and 2 cats. The little kitten at the bottom of the screen, we got him last week. He came home with us last week. So that's very new and exciting in our house, and he is super cute. So in my spare time, I like running and walking. So you can see a picture in the top right of me with my extended family. And we're going over to the Isle of Skye and we're going to do some walking there, which is really fantastic. I also love music and I play in a brass band. And the bottom right-hand picture is a picture of me playing my tenor horn at Christmas in Warwick Marketplace. So I really liked maths and science at school. And when I was doing my A-levels, I went and did a Girls into Engineering Week at Brunel University in London. And that's where I found that I had a real interest in engineering, and that's what I wanted to study at university. So I went to university up in Durham, I studied engineering, and then I joined a company called Midlands Electricity, which is now National Grid Electricity Distribution. And the picture in the bottom left is a picture of me when I'm about 22. And I'm helping to get some customers back on supply. So they've had a fault, they've lost their electricity, and I'm there trying to get them back on supply. I do a little bit less engineering now because I'm more sort of senior in National Grid, but I've had a really exciting career working here. So I've worked in the electricity control centres, I've worked out on site, but I've spent a lot of my career designing electrical power networks and thinking about how we can connect renewable power to our national grid. And that's some of what I'm going to talk about to you all this afternoon. So who is the National Grid? So the National Grid own and operate all the wires and equipment that take the electricity from the sources of generation, like coal-fired power stations and wind farms, to your home. So we own a lot of the kind of big pylons and the wires that you will see when you drive up and down the motorway. And then part of the distribution network, the part that's shown in blue on the map on the right. And there are other companies who own other bits of networks. And you may recognise some of those from where you live and the companies that send you your bills. So we have about 4,500 miles of overhead lines, 1,500 miles of cables, and we connect about 8 million homes and businesses. And we do our job really well in the electricity industry. Our networks are really reliable, and it means that when you go home tonight, you can be fairly confident that when you put your lights on, or perhaps you turn on your Xbox, that everything will work and you'll have electricity. So before we move on, I'm actually in my boss's office, which is really handy because he has some good things that I can show you. So this is one of the cables that carries electricity under the ground. Very heavy. And this is a little bit of overhead line that you kind of see above your heads, perhaps when you're traveling on the motorway. Something that people don't often know about National Grid is that we also own and operate some cables that go under the sea and connect our island with other countries in Europe. And that's really useful because countries like Denmark have got a lot of hydroelectricity and they've got a lot of wind farms as well. So it means that when they've got too much power, they can export it into our country. And that helps us if it's not quite so windy in our country, and we want to make sure we've got that secure supply that I spoke about. So you can see how big the cables are at the bottom. And one of the challenging things actually about laying the cables under the sea is there's only a few boats that can do it. So you can see the pictures in there on the slide of the boats that kind of pull the cables sort of under the sea. And I quite like the picture in the top left because it shows you the wind farms that you can see out at sea. And that's an offshore wind platform. It's got a little helicopter pad on top, but it's where all the electricity from those wind farms comes together, collects it all up, and then it goes sort of onshore to power your homes. So I just wanted to say a little bit about what the network looks like. So I think about our network a little bit like the electricity motorway. So as I said before, it's all about those overhead lines and towers that you see, particularly on motorways, actually. But if you're in London, you won't see those, or Edinburgh or Glasgow or any other big cities, because quite often they're buried under the ground, and they're either buried or they're in tunnels, like the tunnels you can see in the middle picture. But we also want to make sure that we can switch the power so that it can go in different directions depending on where the demand is and where we need it to go. So on the right hand side is one of our substations, and sometimes you can see these. So if you drive past junction 6 of the M6 in Birmingham, for example, you'll see one of these substations, but obviously you can't go in them because electricity is dangerous. And then as you get closer to your homes, the electricity motorway runs at really kind of high voltages. But as you get closer to homes, there's transformers that transform the voltage down to lower voltages and then distribute the electricity to your homes on smaller bits of equipment. So if you live in the country, you might well have seen those wooden poles near your houses. And then if you walk through your estate, quite often you'll see local substations, which is like the one in the first picture that I showed you, where I was doing some of my switching, getting people back on supply. So I now want to talk about some of the challenges that we've got in the electricity industry. So in the past, electricity was mostly generated from fossil fuels. So that's fuels like coal and oil and gas. But we know now that they are sort of really polluting for the environment. They're not great if you've got conditions like asthma. And they're not good from a climate change perspective. So they produce carbon dioxide, which warms our atmosphere. So as an industry, we want to stop using fossil fuels. And actually this year, we'll use the last sort of coal on our system and move towards renewable forms of energy. So that might be wind energy, solar energy, or hydro, particularly if you're in Scotland. So the challenge for us in National Grid is that those sources of energy are not in the same places as the fossil fuel sources. So you don't find the wind farms in the same places that you find the coal-fired power stations. The wind farms are mostly sort of offshore, and the coal stations actually are quite close to some of our motorways, hence where our lines are as well. And as well as needing to build new network to connect these new forms of energy, in the future, we also expect electricity demand to really grow. And that's because more people will have things like electric cars, electric vehicles, and also they will use electricity to heat their homes rather than gas, using things like heat pumps. So we have to cater for the electricity being generated in different places and everybody using more of it. So we're doing this big programme of work, which we're calling the Great Grid Upgrade. And actually, we built the network that we've got today was built in the 1950s. And before that, it was just a collection of different electricity networks. And in the 50s, they were all joined together to make the transmission network that we know today. And we're doing something similar now in that we're doing a really big overhaul of our network and looking to build lots more networks. So we need to build 5 times more lines by 2030 than we've built in the last 30 years. We need 4 times more undersea cables than our current network offshore has got, and we need to do that by 2030. And we need to connect 3 times the amount of electricity generation to our network by 2025. So huge challenges there as well. And the picture on the left makes me smile with the woman on the washing machine. And I hope that in the 2020s, we've got more men using washing machines as well. So to build the electricity grid of the future, we're going to need lots of engineers. I would always say that engineering is for everybody. We need people from all different sorts of backgrounds, and we need lots of them to help us build these networks for the future. It's a really, really exciting job at the minute. And hopefully some of what I've spoken about today will be inspiring and make you think about engineering in the future. And also, hopefully, you'll be taking part in the primary engineer competition. But I wanted to finish with some of the questions and the engineering challenges that we're thinking about at the minute at work. So one of the questions that we're thinking about is, how do we manage this high demand for electricity? So it's going to be a real problem for us if everybody plugs their electric vehicles or turns their kettles on at the same time. So we're thinking about, well, actually, how can we manage that, and how can we smooth out that electricity demand across the day so that we don't need to build as much wires and equipment. And secondly, we're thinking about how do we protect our equipment from climate change? So if we see temperatures rise and perhaps more flooding, how do we make sure that our assets on the ground, the equipment, is still sort of safe and operates and provides electricity? And then thirdly, the final question I've sort of pulled out is, we're building all these new bits of infrastructure, but actually, how do we get more electricity down the lines that we've already got? Because that really means that we don't have to build quite as much. And I've got 3 examples in the bottom of some of the innovation and exciting things that have happened in our industry. I really like the one in the bottom left, actually. It's not an example from the UK, it's an example from the Middle East. But in the UK, if you're building a tower, you take all of the steel out onto site and then you build it like Lego. But in the Middle East, they have these massive sort of helicopters that can bring sections of it and kind of drop it in place, which is super cool. But one thing we are doing in the UK is that we're using robots. And I think this one is called Spot the Dog. And he works in substations where, it's quite dangerous to be in a substation. But Spot the Dog can go in, he can, read the instructions, he or she can read the instructions on the breakers, take measurements, take readings, and actually somebody doesn't need to be on site. They can be sat at their desk and they can be controlling Spot the Dog. So the use of artificial intelligence and sort of digital ways of working is going to be really key for us in the future. And then finally, I don't know if anyone's on the call from Somerset, but we ran a competition in Somerset to design a new pylon for our system. And the winning design is actually one that we've built called a T-pylon. And it's more in tune with the environment. It's not quite as tall as our existing lines. It's a lot more hidden from communities who kind of live next to it, but it can still carry a lot of power. So that was a really great an interesting piece of innovation. And I'm sure you've all got some fantastic ideas, and I really hope you put them into your primary engineer sort of submission. Thank you, and back to you, Scott.
Thank you very much for the presentation. We're now going to move on to the Q&A. If you do have any questions out there, please send them in. I can see some of them have been sent already, but I get the first question as I'm the host, and that is, what do you love most about your job?
Do you know, I really like the fact that I'm making a difference to climate change. So I feel as if we're doing something really worthwhile in the energy industry by connecting up all the renewable sources of energy. So when I get up in the morning, that makes me kind of feel really proud to do the job that I'm doing.
Oh, that's a good answer. So we do have some questions coming in now as well. The first question is, have you been up any of the large power pylons yourself?
Oh, do you know, I haven't. I'm a little bit scared of heights, if I'm honest. But I've climbed some of the wooden poles. You strap these spikes, or you used to, I'm not quite sure if they climb them in quite the same way, but you strap spikes onto your shoes and you sort of poke them in and climb up. So I've climbed up the wooden poles, but I've been a little bit too scared to go up the pylons. They're quite big.
They do look quite big. In fact,
Yeah.
you mentioned that there was you asked people in Somerset to come up with a new design, and in fact, in some of
Yeah.
the pictures, there are different designs. Why are pylons shaped differently?
Well, most of them are sort of shaped of what we'd call the lattice design. And you need to have sort of separation between the conductors as well, which is why they're designed in that kind of way. But you can achieve the same thing with slightly different variations of design. You also need to make sure they're high enough up in the air so that people are safe if you're passing underneath them, because when they get hot, they do sag a little bit.
One of the things you've mentioned that a few times about some of the substations can be quite dangerous. We've even got robots there, so people don't have
Yeah.
to go in. So is
Yeah.
safety? Safety must be a massive part of being an engineer when you're working with electricity.
Yeah, absolutely. So most of the operation that we do is when the substations are dead, so they're not carrying electricity, but not all the time. We do some sort of situations where we do live working. But yeah, safety is very much at the core of what we do at National Grid. And we work hard to make sure that when people come to work, they leave and go home at the end of the day and they're sort of safe. So we've got lots of safety teams, lots of people thinking about how do I stay safe on site. And hopefully that's the first thing people think about before they start work.
I can imagine. So we do have some more questions coming in. I really like this question. Does all the electricity made get used, or is a percentage lost along the way?
It is lost. And it's lost through heating in particular on the overhead lines. So if you think about, we run the networks at high voltages to try and minimise the amount of current that you need for the same amount of power, because it's actually the current that causes the heating, it causes the sag, and you get losses in the network and a little bit of noise. So energy is lost through noise as well. Yeah. And sometimes with the offshore, it's quite hard. With the sort of offshore wind farms, it can be quite hard to use all the energy because the wind's either blowing or it's not.
Mm.
So one of the really exciting things that's happening at the minute is people are thinking about how can we use some of the excess wind energy to make hydrogen, and then think about how we can use kind of hydrogen instead of fossil fuels as well.
So they're always thinking about not only can we use more, but can we make it greener and better for the planet?
Yes. Yeah.
Brilliant.
Yeah.
And so we've got a couple of questions in, some were sent in as well, but these ones are a little bit about yourself, Amanda. And this question comes from Jess, and it's, did you always want to do the job you do now?
No, I always wanted to be an accountant, actually.
Oh, wow.
So I really like, as I say, I really like maths and science. And the only thing I kind of knew about was numbers. And my dad was a maths teacher, and I just thought I'd become an accountant. But as I said, when I was at sixth form, my head of sixth form said, how about engineering? You like maths, you like physics, how about combining it? And he introduced me to the Insight into Engineering course for girls. And then through that, I realised that actually there's so many possibilities with engineering. And I'm really glad that I made that decision.
Sounds like a teacher had quite an influence on you then. I think that.
Oh, absolutely. Yeah. And one of the reasons I love physics is because my physics teacher was so fantastic, a really good teacher.
Oh, brilliant. So the couple of questions we got sent in as well were about the work you've done with National Grid. Now, we saw a picture of you, as you said, in one of the substations. So the two questions we have are, what was the first project you worked on at National Grid, and what's been the biggest project you've worked on?
So one of the first projects was, I used to work out in the field, and I guess one of the first projects I worked on was drawing out a schedule to help upgrade one of those distribution substations in somebody's housing estate. So we were building a new substation because the other one was old and the equipment needed replacing. And then we were feeding the new cables into that substation. So I led that project with some jointers and some fitters, and trained and was authorised to do some of the switching. So that was a really exciting job. I've done lots of really big projects. I've worked on things like the Hinkley project, which is the one with the T pylons connecting up Hinkley nuclear power station. So doing some of the design work behind that, working with some of the big customers like EDF, who are building the nuclear power station. Probably my best job though was working in the electricity control centre, particularly during storms when lots of people are off supply, and it's your job to try and help get their electricity restored. So I feel that's one of the most important jobs that I've done.
Yeah, especially if you're in a storm, it's usually quite cold, so you want to make sure that you've got got electricity to heat your home.
And some people are quite cross about being off supply as well. So
I can imagine, so we've got some questions in the chat coming as well, and this one is: does all the renewable energy generated in Cornwall stay in Cornwall, or does it go across the country? I think you mentioned that we even get some from places like Denmark, so I can imagine electricity is from all over the place.
It goes all over the country, and when you turn on your lights, you can't tell where the electrons come from, unfortunately. But there is an app that you can download that tells you the percentage of renewable energy on any one day on our system.
Oh, really?
Yeah. So that's quite
really
cool.
interesting. So there was a couple of other questions we had actually, which is about the amount of electricity that is used. So the question was, you mentioned about how you don't see these overhead cables in big cities. So do big cities use the most electricity in terms of places, but also what activity uses it? Is it the lights? Is it charging your phone? Is it the heating? So it's sort of where uses the most electricity and what uses the most electricity?
Oh, that's a really good question. I would say sort of industrial processes, but increasingly things like data centers, actually. If you think about all the companies like Amazon and Google processing all those data in the centers that they've got, they use a tremendous amount of electricity. And then it's, people's homes, businesses. And in the future, actually, we don't have much air conditioning in this country, but my role actually looks over the US and the UK. And in the US, they have a very high proportion of air conditioning load. So in the UK, you see peak demand happening in winter when everyone's cold and they're putting on their heating. But in the summer, quite often it's when everyone's using their air conditioning load.
Oh, right. So it's temperature.
Yeah, temperature. Yeah.
Wow. So, well, we've got time for a few more questions. I can see some more in the chat, but if anyone's sitting at their hands any questions, please type them in. This question comes in for, you actually mentioned how many miles of electricity wiring there is in the overhead cables in the UK, but how many pylons are there?
I don't know. Lots. I think we've got something like 235 transmission substations and 4,500 miles of overhead line. I don't know the pylon number. I think it'll be quite big.
I can imagine it's quite high to hold up all those wires. We also had a question about saving energy. So if you said there that you can, I know that you can sort of monitor how much electricity is being used and what devices are using them in your home. But is there any way that schools can save energy?
Yeah, and I think there's a lot that we can all do to manage electricity, and it's a way of trying to reduce demand in the future. And there are some really sort of simple things like making sure that when you leave a room, you turn the lights off, making sure that your buildings are well insulated. So there's often government grants available so that you can insulate your home or your school building well, and that really helps to keep the heat in and save on energy costs.
Oh, that's good advice, actually, especially if there's help out there. It's good to go and find it.
Yeah, absolutely.
So you mentioned that in the UK, winter is the sort of peak usage of electricity. In the US, it's summer. What is the most electricity used during the day? Is there peak times you can actually see where the country starts using more?
So traditionally, it's always been when people get up in the morning, and have a cup of tea, and then when they get home from work. So traditionally the peaks were like 9 and 5 o'clock. But that is going to shift, particularly when people have got electric cars and they're plugging those in. You know, more people are working at home as well, so you don't have so many people going to work and coming back from work. Some people are working at home, so, and we're using more air conditioning as well in the summer because summer's a little bit hotter. So it's kind of evolving, but traditionally it was that kind of people are home from school and work and people are getting up in the morning, that kind of time.
I quite like that. It's like when the kettle goes on, every kettle in the country probably goes on.
What's really interesting, actually, you see really big spikes in electricity demand when you've got big national events like the funeral for the Queen. At the end of that, when everyone sort of turns off the telly, everyone puts their kettle on and you see a big sort of spike. Big football events at half time, the electricity sort of spikes up.
Oh, wow.
It's when everybody's doing the same thing and they're all after electricity at the same time.
Oh, I quite like that because I might be doing that by myself, not knowing that I'm actually joining the rest of the country and doing it. So as I say, we've got time for a few more questions. This question came in after you got the prop, actually. You mentioned that the undersea cable is really heavy. Why is it so heavy?
It's got a lot of metal in it. So if I hold it up, this is copper. And then some insulation, but it's got quite a lot of armour as well to keep the cable sort of safe and also to manage the forces. So it's the materials that make it really heavy.
So one of the things I wondered, and that we also done a question about this. So when we saw that picture of the station next to the offshore wind farm and how there was like a helicopter pad. So the question is, how many people are working offshore when the wind turbines are on? And also, being an engineer, is that working with a lot of people, or do you spend a lot of time working on your own?
I think so. I'm not an expert on the offshore platforms. I suspect some of them are unmanned, and there might be occasions when people need to go out. I think we would want to minimise how many people have offshore, but traditionally people have done jobs where they worked offshore in the oil and gas industry. Yeah. And just repeat the second question.
It was just, is being an engineer working with a lot of people all the time, or do you spend a lot of time working by yourself?
Do you know, it varies. So when I worked in the control room, it was the same people day in, day out, because it takes quite a lot of training to do that job. And when I've done site work, operational work, and I worked in the land team for a little bit, helping the engineers get access to our equipment, then it was lots of people. The job I do now is in a smaller team because it's more strategy focused, and it's more looking across the UK and the US. So we think about what are the problems that we're going to face from an engineering point of view in, I don't know, 2 decades time, and have we got the right engineering capability across our business? And if we have an incident, an engineering incident, how can we learn the lessons and how can we share them across our business? So that's a smaller team for the work that I do today, but I've worked in very large teams in the past.
And it sounds like some exciting people as well, because they all must know so much about electricity and different parts of it.
Yeah, we all love it.
So we've got time for one more question, and I like this question from Jess, and it's what's the best piece of advice you could give to someone who's thinking about getting into engineering?
I would say, so you don't have to be the best in your class at maths or science to want to be an engineer. I genuinely believe that engineering is for everybody. There are so many different engineering jobs that you can do as a young person, that the most important bit of advice I can give you is if you love it and you think it's for you, then go for it. And I'm sure a very exciting kind of job and career awaits.
Oh, I like that. If you love it and you think it's for you, go for it. I think that's brilliant advice. And I think that's excellent advice as well to end this interview on. So I'd just like to say thank you to everyone for joining us, but a massive thank you to Amanda for helping inspire all the engineers in the making out there, because it is your turn to come up with your own engineering ideas. Remember to send them to us once you've finished so we can get our certificates sent out to you, and then we'll hopefully see you all at our in-person exhibitions at the end of the school year. Remember, the deadline for submissions is March 22nd, and we have some of that free post available thanks to the support of Talus. So just get in touch with your contact at Primary Engineer to find out if you can use that. But for now, I want to say a massive thank you again to everyone, but a huge thank you to Amanda. And remember, if you were an engineer, what would you do? Thank you very much, everyone.